Hi everyone. If you have not printed this off, then you're just going to need to follow along kind of carefully. There are times when this webcam gets a little blurry. I apologize for that, but if you have the PDF in front of you, might make it a little easier. Instead of us handwriting out some notes, I found this and thought it might be kind of useful. It's about putting all of the forms of quadratic functions together, standard and factored and vertex. Some of this stuff right up here is a little ahead of us, not all of it, the factored form, for example. But just as a reminder, our standard form right here, factored form, we can see it like this, or we've done it like this where we used r's right here. Okay, and you'll notice that we use subtraction right there. And then vertex form. Important that this was subtraction and that was addition, right? This stuff right here we're going to come back to. And this we're going to talk about probably, I think it's tomorrow. But right now what I want to talk about is converting between the forms, all right? You've already done this, so this is going to be review again. But it's been a little while, so I wanted to talk about it. If we are trying to convert from standard to factored, right? Well, we factor. They're the extra steps that are kind of being mentioned here are probably about the greatest common factor. Remember, when we're trying to factor, we can use this x method of what multiplies to be a times c but adds to be b, right? If it's helpful to you, you can use the area model, right? Where you split the b value along here. That's what this is all about, trying to help you figure out how to split it along the diagonal. And then you try and find the factors, the length and the width, that multiply to give you that standard form, okay? All right, if we switch down here, trying to go from standard to vertex, well, the way we do that is by completing the square. This part, we're going to get there eventually, but we're not probably far enough ahead that we could do that right now. And really with the completing the square, remember we also would probably use this, area model. And, your x squared stays here, whatever it is, and then this b value gets split equally, remember? We kick out whatever that c was, right? And then we complete this square by adding a certain number right here, and then we subtract that number again, right? Whatever that is, okay? All right, if we're given factored form and we want to move it to standard, well, really all we're going to do is multiply. You can distribute, you can do a multiplying table, which is that area model, or FOIL. If you remember, FOIL is just where we do this kind of FOIL face, remember? Yeah, and that's first, outer, inner, and last. That's multiplying our binomials, all right? Or, you could also multiply it in this area model, right? In your first terms, right? Your outer terms, your inner, and your last. And then you combine all those, combine them. And then if we have vertex form that we are trying to get to standard, we just follow order of operations. And sometimes, we forget some of those. Parentheses, exponent, multiply, divide, add, subtract, right? Basically, you're going to do what's in the exponents first, okay, by doing probably FOIL, because it's probably going to be that you have a binomial that's getting squared, right? So you FOIL that binomial. Then you're probably going to multiply it by the a value, if there is one, okay? So that's the second step. And then this adding is probably your third step, which is just your combining your like terms, okay? Now, there are some examples down here, like one and not the other, right? Oh, one more thing. If you want to get back and forth, you notice that it didn't mention up here between factored and vertex, is because you got to use standard form. So you convert from factored to standard, then you can get to vertex, or you convert from vertex to standard, and then you can get to factored, right? So standard is like your in-between step they're saying here. All right, so here's an example of converting this factored form into vertex form. All right, well, first you're going to have to get it into standard form, right? So first you're going to multiply. Here's where you're going to do that FOIL method right here, right? You do that FOIL first and then multiply by 3, distribute that 3 through. Here, if we were going to take it from this standard form to try to get it to vertex, first thing is you got to factor the 3 out. They're leaving a little space for you to, say, well, what would complete that square? And in our case, all right, it would be 16. Okay. If we add 16 here, we subtract 16 here. Now there's one weird little quirk about this example where they did not divide 36 by 3, which we have done. So this would be 12, right? And we would have this as our brackets around the whole thing, right? So I'm going to change it down here too. Okay. Actually, just put minus 16 right there. Okay. Where occasionally I used a pencil. Right? And then this part right here, right? We would simplify to x minus 4 squared. That's the perfect square trinomial. And then this part right here, a positive 12, negative 16, that becomes negative 4. And we distribute that 3 to both of these, so we would get 3x minus 4 squared minus 12. Okay. Now don't worry if that example isn't that great for you. We're going to do a couple in our next lesson. I just wanted this as kind of the jumping off point for the next part of our lesson, okay?